We present the IKEA Assembly Dataset, a new dataset for understanding furniture assembly using actions, objects, and poses. The availability of a large labeled dataset is a key requirement for applying deep learning methods to solve various computer vision tasks. In the context of understanding human activity, existing datasets, while large in size, are often limited to a single RGB camera and provide only per frame or per clip action annotations. To enable richer analysis and understanding of human activities in the context of furniture assembly, we introduced the IKEA Assembly Dataset. Each assembly in our dataset contains a sequence of frames from 3 RGB views, 1 depth view, and several annotation modalities which include atomic action, human pose, and instance segmentation. For segmentation and human pose annotation, we manually labeled 1% of the dataset comprising of manually selected keyframes that cover diverse object poses and human poses. Our dataset contains 48 people assembling 4 furniture types in 3 different colors, captured in 5 unique environments and on 2 assembly work surfaces, floor and tabletop. In total, the dataset is composed of 371 assembly videos comprising of approximately 3 million frames and 35 hours of footage. We provide a standard environment-based trained test split and a script to create auxiliary splits based on other criteria, like assembler ID, actions, and environments. We evaluate prominent methods on several computer vision tasks, including action recognition, 3D human pose estimation, part instance segmentation, and object part tracking. For full details, please refer to the paper. For action recognition, we tested single frame-based methods using ResNet architecture as baselines and sequence-based methods including I3D, C3D, and P3D. The results show that the dataset poses a great challenge for action recognition. We also evaluate the effect of using different modalities for making action predictions and inspect the different views, the depth, the human pose, and their combinations. The results show that combining RGB data with pose information yields the best result. For the human pose benchmark, we evaluate both 2D and 3D methods. We perform inference using pre-trained and fine-tuned models from the original papers. The results show that the dataset is very challenging for this task due to the complex and unique poses people exhibit while assembling furniture. To evaluate the performance of existing instance segmentation methods on almost textureless IKEA furniture, we trained Mask RCNN with several ResNets with feature pyramid network architecture. We also report the effect of adding pseudo-ground truth frames, adding point rand head, choosing a specific furniture color, or background environment on the performance of the instance segmentation task. Although Mask RCNN shows promising results in many scenarios, there are also failure cases reflecting the real-world challenges introduced by our dataset. These failures are often due to relatively high similarities between different assembly parts or relatively high similarities between assembly parts and the environment parts, which introduce false positives. In summary, the IKEA ASM dataset is a large-scale, comprehensively labeled furniture assembly dataset for understanding task-oriented human activities. Our dataset provides a challenging testbed for computer vision algorithms such as action recognition, textureless object segmentation and tracking, and human pose estimation in multiple views. The dataset is publicly available for download. The training and evaluation code is available on GitHub. Thank you for watching.